All right, today we're going to talk about lesson 6-4, slope-intercept equations for lines. Two things that you need to have to do slope-intercept form of a line for the equation. You have to know slope, and then the intercept that we have to know is the y-intercept. You find the y-intercept when x equals 0. So the big idea, the line that contains the point 0, comma b, x is 0, and the slope m has an equation y equals mx plus b. So you put your slope where the m's at, you put your y-intercept where the b's at. Now obviously if your y-intercept is a -3, you wouldn't have plus a -3, you would just simply write -3. Okay? Looking at these graphs over here to the right, this is where I want you to look at your point of interest. But if I wanted to find the slope of this line, I could pick 2 points on this line, or I could do my rise or run from 2 points. By looking at this, from this point to, let's say, this point right here, my rise is 1, my run is 2. My rise is 1, my run is 2. So rise over run, which is my slope, would be 1/2, and it looks like it's going to be the same for all 3 of these graphs. So my slope for all these is 1/2. The point of interest that I want to make on these pictures besides the slope is also the y-intercept. The y-intercept is where the equation crosses the y-axis. Our y-axis is found by this vertical line going up and down. The point where it crosses the y-axis is right here, which is 0, comma, -6. So in this case, our y-intercept is b, which is a -6. Looking at this graph right here, where does it cross the y-axis? It crosses the y-axis right here. In this case, it crosses at a -2. So in this case, b equals a -2. On this graph down here, we're up in the positive sector of our y-axis, but our y-axis crosses right here at 8, so our y-intercept is at 8. So that's a very easy way that you can find out what your y-intercept is, just simply by looking at a graph. Using the slope-intercept form of an equation of a line. Slopes and y-intercepts can be seen in equations of real-world situations. Suppose Judy is going on vacation to Istanbul. The airfare is $940, and she expects to spend $300 per day for a hotel and expenses. Then after X days, the total cost Y of her trip is given by the equation Y equals 940 plus 300X. She's going to start with 940 is what she has spent, and then every single day she is going to spend $300 after that. For every single day, and we don't know how many days we're going to spend. Okay? In order to graph this, we know we're starting at 940. So here's my y-intercept, 0, 940. And then my slope is we're going up $300 to the right 1. So my slope is 300 over 1. It says, notice how the 2 key numbers in Jody's expenses appear in the equation. Her starting cost of $940 is the y-intercept. $300 cost per day is her slope. Okay, she started with $940, and then every single day she increases $300. So by the 6th day, we could say she's going to be approximately at spending $2,750. Let's look at Quiz Yourself 1. It says, find the slope of the y-intercept of y equals 1/4 x plus 11. Okay? I'm going to turn it over to the capture view. But looking at this, we need to find slope and the y-intercept of y equals 1/4 plus x. If you remember, the slope is what's in front of the x value, or the x symbol. What's in front of the x? Slope is equal to, it's 1/4. My y-intercept in this form is everything that comes afterwards, which in this case is 11. B says, and I'm going to do B down here, B says, write an equation in slope-intercept form for the line with slope 3 and y-intercept of a -7. Well, I need my y equals, and then what goes here, remember it's mx plus b, m is my slope, so y equals, m is my slope is 3. Don't forget your x, that x has to go with it. My y-intercept is a -7, so my -7 goes right after it. So an equation for the line that has slope 3 and the y-intercept of a -7 is y equals 3x minus 7. Moving on. The same line could have many equations. For example, 3x plus y equals 7, 30x plus 10y is equal to 70, and y equals a -3x plus 7 are all equations for the same line. Notice, to go from here to there, you just move 3x over to the other side. To go from here to this equation, all they did was multiply every single term by 10. Let's do quiz yourself too. It says give the slope and the y-intercept of y equals a -2 minus 6x. Now, you could rewrite it in the form that we're used to. mx plus b. This is not an mx plus b form. We can put it in the mx plus b form. Let's do that. So this is y equals a -6x minus 2. Now we are in mx plus b form. So what we know is the slope is, what's in front of the x? What's in front of the x? It is a -6. My y-intercept is everything else, which is, in this case, a -2. Slope-intercept equations allow us to get information about a line quickly. For this reason, it is often helpful to convert other equations for lines into slope-intercept form. Example 1 says write the equation 3x plus 7y equals 9 in slope-intercept form. Give the slope and the y-intercept of the graph. To do this, what we need to do is we need to solve for y. That's going to take our standard equation and put it into slope-intercept form. So to put it into slope-intercept form, what you have to do is you have to solve for y. So let's do that. First thing we need to do is move 3x over to the other side. So the inverse of adding 3x is subtracting 3x. Whatever I do to one side, I have to do to the other side. My 3x's are gone here, leaves me with 7y equals, now remember, 9 minus 3x, those two things are different. So we just write it as 9 minus 3x. Then what do I need to do? I still got to get y by itself, so now I need to divide by 7. Whatever I do to one side, I have to do to the other side. So y equals 9 over 7 minus 3 over 7 x. Don't forget that x. So this is my equation now written into slope-intercept form. I'm not going to move it around. I feel that we're able to find the slope and the y-intercept for this. So it says give the slope and the y-intercept for the graph. My slope is what is in front of the x. The number that is in front of the x is a negative 3/7. My y-intercept is everything else over here, which is 9/7. Pretty simple. Moving on. Recall that every vertical line has an equation of the form x equals h. That's a vertical line. That means it's undefined slope, as we should have learned in 6-3, where h is some fixed number. Could be 2, could be 1/2, could be 5 1/3. Equations of this form clearly cannot be solved for y. Thus, equations of vertical lines cannot be written in slope-intercept form, and they cannot be graphed on many graphing calculators. This confirms that the slope of vertical lines cannot be defined. Okay? Writing an equation for a line from its graph. The graph of a line gives information that can be used to write its equation. Example 2. Find the equation of the line graphed at the right. First thing we might want to do is find the slope. Okay? We need slope. So I'm going to pick 2 points that are on this line. Well, I see one point right here. That is also my y-intercept because it is found at 0, a negative 25. That's also my y-intercept. I can find another point right here, which is at 10, negative 10. So, I do know my y-intercept, but I have to find out my slope. My y-intercept is a negative 25. 0, comma b. What's b? A negative 25. So, I'm going to call this x1. I'm going to call this y1. I'm going to call this x2. I'm going to call this y2. Okay? And I'm going to find slope now. So, slope is y2, which is a negative 10, minus y1, which is a negative 25, divided by x2, which is 10, minus x1, which is 0. Well, 10 minus 0 is 10. A negative 10 minus a minus 25. Minus a minus is plus. So a negative 10 plus 25, we should all know, is 15. And when we divide by 10, we move it 1 unit to the left, and it gives us 1.5. So my slope is equal to 1.5. So now for my equation, I'm going to put it in the slope-intercept form. My equation is going to be y equals slope, which is 1.5, x, and then my y-intercept is a negative 25, so I write minus 25. And this is the equation for this line that is graphed. It is a lot of points, but if you take your time and understand what you're doing with your information, you're bound to get your answer. Every constant increase or a constant decrease situation can be described by an equation whose graph is a line. The y-intercept of that line can be interpreted as the starting amount. Y-intercept is the starting amount. The slope of that line is the amount of increase or decrease per unit. Okay? That's very important information right there for some of you. You're going to want to write that down. And then we're going to take a look at this next example. The y-intercept of a line can be interpreted as the starting amount. Okay, it's how much you start with. The slope of the line is the amount of increase or decrease. Those are two key points of information. So let's look at example 3. Assume that a skyscraper opens a parachute and falls at a speed of 10 feet per second from 5,000 feet above ground. Okay, where's our starting point? Okay, well, our starting point is 5,000 feet above ground. Okay, which then is my y-intercept. My slope is this little tidbit of information, a rate. Okay, it's a rate, 10 feet per second. Slope is a rate. So my slope is 10. A says, find a slope-intercept equation for the height h of the skydiver after x seconds. So my equation for this is going to be y equals slope, which is 10, x, because we don't know how many seconds it takes, plus my y-intercept. He's above ground, so it's plus 5,000 feet. There's my equation for this example here. B says, how high is the skydiver after 5 minutes? Well, we got an equation in terms of seconds. So the first thing we need to do, 5 minutes is equal to how many seconds? Well, we all know there are 60 seconds in 1 minute. So 60 seconds times 5 minutes is 300 seconds. Now that I know how high, now we want to know how high is the skydiver after 5 minutes. 300 seconds. Okay. Oh, Mr. Johnson made a mistake. We are falling at a speed of 10 feet. So this slope should be a negative 10. Yeah. If you fall, you should be going downwards, right? We're not going to increase going up if we're falling down to the ground. So, to find out where the skydiver is at after 300 seconds, oops, I didn't even see that, then we need to put 300 in for x. So y equals negative 10 times 300 plus 5,000. Well, what's a negative 10 times 300? All of you should be saying a negative 3,000. Plus 5,000. Negative 3,000 plus 5,000 is 2,000 feet. So, at 300 seconds, or 5 minutes, my skydiver is at 2,000 feet in the air. All right, last thing we need to talk about is direct variation. Direct variation is a special case of a linear equation occurs when the y-intercept is at the origin, which means your y-intercept is 0, and y equals mx plus 0, which means you ain't going to have nothing seen here, which then becomes y equals mx. This means that y is a constant multiple of x, as shown below. If you notice here, here's a line that goes through the origin, and its slope is down 1 to the right 2. Therefore, the equation of this line is y equals a negative 1/2 x. If you look at this line here, the once again goes through the origin, which means our y-intercept is 0. Okay, and our slope is up 5 to the right 1. So our equation for this line is y equals 5x. Now remember, you don't have to put plus 0. When y is a constant multiple of x, it is said that y varies directly as x. So we call this situation direct variation. The amount you multiply each x by to get y is the slope, also called the constant of variation. So in this example up here, the constant of variation in this equation is a negative 1/2. The constant of variation in this problem is 5. So let's look at Quiz Yourself 3. Determine which equation is an example of direct variation and give its constant of variation. Well, if you look at this, this has a slope, this has a y-intercept. This one down here is a horizontal line that will never go through the origin. Therefore, that can't be it. Therefore, it's this one. Okay, it has no y-intercept, but it does have a slope. The constant of variation in this case is 3/4. Thank you very much, and I'll see you tomorrow.